All right, so we've already done this example in class, but I just want to work it out. So we've got a record of this. So we've already talked about what a sampling distribution for a proportion would be on the first page of these notes, and we derived how we can find formulas for the mean and the standard error. So just to summarize those points, when we have essential limit theorem and we're looking at the distribution of sample proportions, the shape of that distribution is going to be normal. It's going to have a mean which is equal to the population proportion. I shouldn't say mean here. This should be the proportion of the population P. Let me cross that out. And it's going to have a standard error which is equal to the square root of P times 1 minus P over N. And we proved that in class actually last week. And so if we know, for example, that we've got a population which is all of the US residents in the 5 largest cities, and we know that out of those people, 48% based on census data speak a language other than English at home. If we were to pick a random sample of 150 people from these 5 largest cities in the US, what's the probability that at most 40% of them speak a language other than English at home? Okay, so the first question is, are our samples large enough to use the essential limit theorem? And in order to use the essential limit theorem for proportion, we'd want to check that both n times p is bigger than or equal to 10 and n times 1 minus p is bigger than or equal to 10. So in other words, p is the population proportion, n is the sample size. So what we'd like to know is in my sample of size n that I should get at least 10 successes and at least 10 failures. So in this case, we've got n, which is 150, times p, which is 0.48. And when I calculate that product, I get 72, which is bigger than 10. Awesome. And then I would take my sample size, 150, multiply by 1 minus p, which in this case would be 0.52. That gives me 78. That is indeed bigger than 10. Great. So if I pick a sample of 150, I should expect to get about 72 people that do speak a language other than English at home, 78 that don't, and therefore each of those is bigger than 10, so we're good to go. And if I want to use the essential limit theorem to calculate this proportion, one way that I can do it is to find the z-score of 0.4. So keep in mind here that I don't want to use the distribution for the population. I want to use the central limit theorem, which says p hat is going to be distributed according to a normal distribution. The center, in this case, the mean would be 0.48. I should expect on average to get the population proportion, and the standard error is going to equal p times 1 minus p all over n, which is 150. And so if we calculate these, we get the 0.48 where things should be centered, and calculating that would give me the standard error, would give me 0.041. So now the z-score would equal the sample proportion that I'm working with, the 0.4, minus the center of the sampling distribution for the proportion, all divided by the standard error for the sampling distribution of the proportion. So I'm going to get the 0.4 minus the 0.48 and divide all of that by 0.041. And that comes out to about minus 1.95. Okay, so that means this sample proportion of 0.4 from a sample of 150 people, it is almost 2 standard errors below the expected value of 0.48. So if we wanted to calculate in part C, well, what's the probability that a random sample of 150 people that's speaking a language other than English at home is at most 40%? Then we want to calculate what's the probability that p hat is less than or equal to, not 0.48, 0.40. And we could use the work that from the previous part that says we found that the z-score for this is minus 1.95. And then we could look this up using the standard normal distribution table, for example, and get 0.0256, or you could use R if you wanted to get this value. So we would see that it's not really likely. There's about 2.5% chance that we would get a sample of 150 people, which has at most 40% of the people that speak a language other than English at home.